Okay, so in the previous tutorial we have added distance matching for stop state and the cycle state, and let's look at the rest of the states that we can add the distance matching. Right, so yeah, let me look at my documentation first. Yeah, that's the next state. We can consider the pivot, right? Because if you check the pivot now, you can see the foot sliding is there. See, so we need to fix that thing. Right, so where can we start? So the pivot, we have this state machine. And there we have this update pivot anim layer function, right? Okay. And at the setup, what do we have? The setup is simply specifying the explicit type. Okay, let me quickly look at my documentation. Okay, yeah, simply setup is explicit time here. It should be fine. And then at the update pivot anim layer function, we are simply advancing the time for now, but ideally we should apply the distance matching rules here, right? So at this sequence pin, we check the last pivot time and determine the new desired sequence and apply the set sequence with inertial blending, and we capture the pivot starting acceleration. Should be fine, right? And then I think we can remove the sequence pin from here and attach it to here. And then inside this sequence, let's remove this return pin and let's apply this acceleration check to this pin. Okay, so if we are accelerating opposite to the velocity direction, then what? Then we have distance match, right? Distance match to that specific target point. Else, we can capture the stride warping pivot alpha and we can advance the time. Okay, the first at here, I'll add the pin called, or not the pin actually, it's a function called distance match to target. Okay, so let's attach the corresponding sequence evaluator node, convert to sequence evaluator, and distance to target we have to predict it and determine, right? So the similar to what we did at here, get predicted stop distance, let's create a new function called what? Get predicted pivot distance, right? And I'll make it as constant, thread safe, and pure function, and assign it to the distance matching category, right? So like we did before, there is a function called actually provided by the locomotion library called this one, predict ground movement pivot location, right? So if I get the vector length of the xy, this is basically the pivot distance, right? So let's return it. And like we did before, we need to plug the corresponding variables to here. So let's get the movement component and get what? Get, do we have get current acceleration? Yeah, get current acceleration. Attach it to the acceleration. And let's get the property access pin. Get movement component. Then we need to plug the get last update velocity as the velocity. And as the ground friction, get movement component, a variable called ground friction. Okay. So based on that, we can predict the movement pivot location. And if we get the vector length, we will get the pivot distance. Okay, let's go back to the update pivot anim layer function. And inside this function, let's call get predicted pivot distance and attach it to it. And as the distance curve, I can use the same variable that we used before. Okay, so if everything is done, then we can simply return. And if we are not moving opposed to the velocity direction, acceleration direction, then we can advance the time by distance matching. Advance time by distance matching. Let's get the context and the sequence will return out to here. And as the distance traveled, we can use the get displacement since last update. We add this pin at the start advanced time by distance matching state as well. Similar to the pivot, we can use the same variable. And as the curve, like usual, we can use the distance curve. But for the play rate clamp, we can use this pivot play rate clamp, which is here. So I'll break it and I need to lerp the float values for this one, 0, and with this one. And as the alpha, let's use the stride warping pivot alpha. So this one is calculated at where? At here, right? Stride warping alpha. And then let's make a vector 2D at here. And as the x value, I'll use this one, and as the y value, I'll use the y pin of the play rate clamp of pivot. Okay, so that's how we advance time by distance matching for pivot. And let's return it as well. Compile and save. And let's play test it again. Okay, now you can see at pivot we have the corresponding clamp, but you can see like the clamp is too much, the play rate actually too much for the pivot. So maybe we need to reduce this stuff, right? So let's go to the data table instance, and at the jog, let's make the distance matching play rate clamp pivot as 0.625. Okay. We can, what if we increased it further, maybe like for 3? Yeah, it's too much. Let's make it as 0.1. Yeah, now the play rate is reduced, but still I'm not quite happy with the result. Maybe I'll keep this one as what? This one as 0.6 like we had before. Yeah, it real quick and see what it can be done. Yeah, maybe let's try to add a 0.2 lerp here. And as the data table, I just set the red clamp pivot as 0.6 to 5. Let's play test it again. Still it seems the play rate clamp is too much. Yeah, so let's try to unplug this displacement since last update from the distance travel. And now let's try. Okay, now it seems working, right? The pivotal changes happen. Okay, maybe later on actually we can plug this pin if required, but for now I think let's keep it as 0, right? And it works properly, right? Okay, so for the reference I'll add a to do called try plug in the displacement since last update, right? But ideally if we set the distance traveled as 0, it works pretty much fine, right? You can see like it's extremely accurate, right? No foot sliding at the pivot, not even forward pivot or a backward pivot. Okay, let's try the crouch. Okay, it works. Let's try the walk. Walk also, it works pretty much fine. Okay, right, now I think almost all the locomotion states are done except one thing. So if you remember at the anim graph where we had jump fall land, I added this sequence evaluator, and there inside the update fall land anim layer I add this to do called add distance matching for jumps. At previous actually we just add the advanced time feature because I haven't covered the distance matching part yet when we are discussing this jump states. But now I think it's a good time to introduce this distance matching for our state matching, state transitions. Not the state transition actually, the state node functions. Right, so I'll add remove this comment and this pin, and instead of simply advancing the time, let's use the distance match to target. Right, and for the distance to target, let's use the ground distance. Right, so in case if you forgot where did we use this ground distance, we created a separate function called set ground distance, and we do a line trace and determine the distance for ground, right? Right. And for the curve name, I think we can use a different curve, right? So for example, if you look at the what general jump for land anim, here we have this curve, ground distance curve. So let's use that curve instead of using the distance curve. So inside here, I'll name the curve as ground distance, and let's promote it to a variable called curve jump distance curve. Okay, now let's try the jump. Now you can see based on the fall we have that distance matching. Okay, great. Yeah, I think that's all for our distance matching. Maybe later on we can do some cleanups and improvements. For a cleanup, actually I think we don't need this play rate clamp stop, because if you look at the references, it doesn't have any sort of a reference. Because if you look at the stop state, here we use the update stop anim layer. So since we are using this distance match to target, actually it doesn't have a play rate clamp, right? So for stop, I don't think we need to have this variable. So this is a deprecated variable or unused variable, so we can remove these things. Plus there are some improvements and code organizations that we can do. So maybe I'll do those stuff at the next tutorial as a fix up. Okay, so that's it for today, and thank you. See you there.